Hello, this is a lesson video on Precalculus section 9.5 series. Hopefully by the end of this video you will be able to use sigma notation to find finite sums of terms in arithmetic and geometric sequences. And you should also be able to find sums of convergent geometric series. What I'm going to do here is talk briefly about the main concepts to help you get a start on 9.5. To start with, we have what's called summation notation. That uses this big E looking symbol, which is sigma. That's what we call sigma. And basically what this is saying is that the sum of the terms of the sequence, maybe some sequence, is denoted in this way, which means when you add up all the terms, or I should say what this is saying is you need to add up all the terms from the first term to the nth term, and then this a sub k would generally be the rule that gets you the value of each term. The variable k is called the index of summation, as a side note. And of course, feel free to pause this as needed. The sum of a finite arithmetic sequence with a common difference d can be found in the following way. If you have the terms of the sequence written out, so you have the first term, second term, and all the terms up to the nth term written out, when you're trying to find the sum, you know it's a finite arithmetic sequence because there's an n term. If there wasn't an n term, it'd be an infinite sequence. Well, in order to add all the terms up when we're talking an arithmetic sequence, remember that's when there's a difference, a common difference between each term, each consecutive term. All you need to do is take n, which is the number of terms you're dealing with, times the first and last term added together divided by 2. This is another way to write that. If you don't know the last term, but you know how many there are, you can take n over 2 times 2 times the first term plus n minus 1 times the difference, the common difference d. So I would write these down. Basically, all that information will help you find the sum of a finite arithmetic sequence. And then below here is an example. Consider the series 1 plus 2 plus 3 plus ... all the way up to n. We want to find an explicit rule for the sum t sub n of the series, where t sub n is just what the sum is. Well, to find that, we can just solve algebraically. We've got the rule from above, right here. And what we can do is, we can plug in a sub 1, which is 1, and we can plug a sub n in, which in this case is n. And of course, we still go to the nth term and divide by 2. That stays the same. Simplify that out. You have n times n plus 1 over 2. So that's when we go to the nth term. Now, consider that nth term being 100. Consider that nth term being 100. So the same case. So you have that information. Now, use the rules to find the sum of the series from 1 to 100. Well, to do that, you're going to use n equals 100. So you'll rewrite the series in such a way, ... should be right in here. And then plug in 100 for n and for a sub n, since they're the same in this case, and you get your sum. Simple as that. Here's another example, adding the terms or summing the terms of an arithmetic sequence. A corner section of a stadium has 6 seats along the front row. Each successive row has 3 more seats than the row preceding it. If the top row has 24 seats, how many seats are in the entire section? So basically, you have a finite arithmetic sequence here. You know that the the first term would be 6. That's how many seats are in the first row. The last term would be 24. That's how many are in the 24th row. Each successive row has 3 more seats than the row preceding it. Now, so that's going to be your common difference. Now, I'm not looking for you to write out 6 plus 9 plus 12 plus and so on up to 24 and add them up. I'm looking for you to write out a shortcut or a formula. So to do that, we write that information that I just mentioned down. The first row, a sub 1 is 6. The last row, a sub n, is 24. The common difference is 3. And now we're going to solve using that formula we wrote down earlier. It uses a sub 1, n, and d, and we know a sub n is 24. We know a sub 1 is 6. We know d is 3. This is going to help us solve for n. Once we solve for n, then we can figure out the number of seats by plugging that in to our other sum equation. So now the first term was 6, the last term was 24, divided by 2. We now know n is 7, so we can get that there's 105 chairs there, or 105 seats in that section of the stadium. I know, pretty awesome. You're going to be figuring out how many seats are in stadiums all the time now. Use the same type of information for a finite geometric sequence. So make sure you have written this stuff down. We're talking finite geometric. So these are the terms that we're looking at in the sequence. And it has a common ratio, r. Well, if we're looking for the finite sum, and we know it's a geometric sequence, this is the formula to get that sum. You take the first term times 1 minus r raised to the n, so that'd be how many terms there are, divided by 1 minus r. So in this one, we could take a look at, to apply what we just were talking about, we could take a look at number 15. 15, it says, find the sum of the geometric sequence. I've written this sequence here, that's 42, 7, 7, 6, dot, 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 to 42 times 1 6 to the 8th. Well, if we look at this term, this is the same as saying 42 times 1 6 to the 0. This one would be 42 times 1 6 to the first, and then this one would be 42 times 1 6 to the second, and so on, all the way up to the 8th. So how many terms would there be? Well, there'd be 9. Since we started at 0 and went up to 8, that's 9 terms. From there, I'd use that formula we were just discussing right here. So I need the first term times 1 minus r to the n over 1 minus n, or 1 minus r, excuse me. So the first term was 42. Need to take that times 1 minus r is obviously 1 6th, and then I'm going to raise that to the n, which is 9. Oops. And then divide that by 1 minus r, and that'll give us the sum, which in this case is about 50.4. And that's just a simple application of what we were just discussing. There's also what's called an infinite series. Well, if it's an infinite series, what happens is when we use our summation notation, it works the same way, only we go from 1 to infinity. That's the rule again. So if you saw it written out, you'd have the first term, second term, dot, 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 kind of the rule or the nth term, and then plus dot, dot, dot. So it would end with a dot, 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 showing it goes on forever. So what we do with those is we'll see if they converge or diverge, just like in the last section. And then you can also look specifically at the sum of an infinite geometric series. So then, same beginning. We'll go from k is 1 to infinity, and then it's just the geometric series, a times r to the k minus 1. Now here's what you need to note. That will converge if and only if the absolute value of r is less than 1. The absolute value of r is less than 1. So that means r would need to be between -1 and 1 and not including 1 and -1. If it does converge, so if that's true, then the sum will equal a over 1 minus r. If the absolute value of r is not less than 1, well then it diverges. It does not converge. So here's an example of that. Determine whether the series converges. If it converges, give the sum. Well, here's the series. Since the absolute value of r is 0.25, which is less than 1, you know that r value is right there, then the series converges. It's as simple as that. How do you get what it converges to, or what the sum is? A over 1 minus r. A is 2, right there. 1 minus r is 1 minus 0.25. That's what it converges to. And that's all I had for major notes to take on this section. So now I'll just go over a couple example problems if you want some help with that. On 17 through 22, you'll be asked to find the sum of the n terms in the sequence and then tell if the sequence is either arithmetic or geometric. So if we just look at 17, well, if we look at 17 there, we don't have a lot of terms, but the terms that are there, we see a common difference of 3. So that makes me think arithmetic. Arithmetic, common difference of 3. The first term is 2. We want to go to the 10th term, so n would equal 10. And then from there, I mean, if you look back at your notes on finding the sum of a finite arithmetic sequence, you just plug everything into this. Plug everything. You've got n, you've got a sub 1, you've got d. You're home free from there. That's all I have time to make right now. I'll tweet this out. I'll put it on the class page. Perhaps your teacher will show this while I'm gone. But if you have other questions, try tweeting some questions out, and if I have time, I'll respond to those. So good luck, and we'll see you soon.